Hello everyone, I'm Jithender from group G390 and I'm super excited to show you our prototype, the stale fruit detector. It is powered by a Swin Transformer model and instantly tell whether a fruit is fresh or stale just from an image with high accuracy or real-time results in a perfect for reducing food wastage in cold storage and supply chains. Let us jump right now into the action. This is a front page and we have simple easy 3 steps. Upload an image, AI analysis and get the result. Then after we need to log in as I have already logged in through my mail and the password. Then after we have an upload an image. We need to select an image and we need to upload an image. As of now, I'm uploading a stale apple. As you can see that fruit type is apple and detected is stale fruit and the confidence is 99.2. As we will check for another one. Now we will upload a banana image and fruit type is banana and the freshness is detected is fresh fruit detected and the confidence is 85.5. Then after we can see the results according to the sign in username. Right now till now we have checked the two predictions, stale apple and stale banana. Then after we have a model info. We have worked on Swin Transformer model, and this is a model performance matrix. These are model development process. Let us now jump into the code part. What is the actual schema around this? As you can see that this is the first sign in page. This is the first sign in page, and the sign in page code is this. Yeah, this is what the code. This code says is manage a user inputs and from level error messages. This part of the code. Then after this part of the code says as the user is logging successfully and it is redirecting to the dashboard. And this part of the code says that if the credentials are wrong, then it says the login failed and using invalid credentials. As you can see that now we will sign up. As you can see that I'm creating a new account. As you can see that I have my mail is sf@gmail.com and I have provided the password. Then when you click on the password, it goes to the and this is the sign up page for that. and and this part of the code, this is main part. If in the previous slide we have created account, right? And this is this user feedback with toast shows success for failure messages using a toast notifications, and that part of the code is most important. This is the actual schema. Then after we are going to upload an image, right? So we go to the upload page. Yeah, and this is what the upload page. And this upload page, this is the main one. This is the main part. Yeah. Yeah, this function triggers when an image file is selected. It extracts a file passing through the process upload file function. And this part of the code saves to the history. And this part of the code contains the header of the page, including the titles and description of the fruit freshness detection system. The motion diff is animated using the fade in variant. Yeah, yeah. And this part of the code says the status of the message. And this is the result section. And here we can see the image preview after uploading in the database. Yeah. Then after we'll go into my history page. The history part is saved here, and the history part is. Yeah. And this part of the code uses a custom reactor we have created. This likely provide access to the current load image in user information. And this is the main logic. The main logic of the code is this block is responsible for fetching the prediction history and the login for user and backend API. And the main the functions are purpose, dependency, function execution, API calls, error handling, setting state, loading state, and abort if no user. And these all parts are animation parts. Now let us dive into the our main model, where our main model is in the model. The main part is patch embedding. In this patch embedding, image is converted into the image patches tokens using a convolution with stride equals to patch size. Then after we go to the Windows partition and reverse. This part of the code takes the image, splits the image input features map into overlapping windows for localized self attentions, recursed for the original spatial shape after attention it applies. And this is what the window attention. In this window attention applies attention within each window for computation efficiency. Scale dot protect attention and project the results. And this is the main swing Swin Transformer block. In this Swin Transformer block, the core building block combining layer norm, shifted windows, window attention, MLP, result connection, and alternates between the shifted windows. And this is a cyclic shift according to the patches. This is a partition window. This is a MSA, and this is a merge windows, merging the windows. Then after this part of the code is downsampling layer, merges 2 by 2 neighborhood patches, reduces resolution, increases channel dimension, applies between swing stages. And here we come for the swing transformer stage. A sequence of swing blocks can include a patch embedding downsample at the end. Here it is a main swing transformer block. This main swing transformer block contains end-to-end image coder, patch embedding, 4 swing stages, final layer, global average pooling, classification head. And this part of the code says that after training the code, we should save the code. And this is the main code. Find functions to load the model and weights. Loads the trained weights, returns a model eval instance ready for instance. Loads the weight to the CPU explicitly. Then after we go into the predict.py and our model predict.py. And when you click on the select image, it goes to the model.py. Then after it comes to the after selecting an image, this status. Yeah, this status is sent to the predict.py. In this predict.py, we have mainly trained our model in the six fruits. These are the class names. Then after this is a pre-processing transform. It resets the image to 224 by 224, normalized with mean and standard of 0.5 across RGB channels, matches the training settings. And this part of the code, this part of the code gives the API information. Process the image, ensures the 3 channels, applies transform and add batch dimensions. And run interface turns a gradients and faster. This part of the code says that turns off gradients for faster interface, applies softmax to the class probabilities. And this is the history page. In this history page, is connected to the .ev file. And this ev file is a MongoDB URL. And right now I will show you the MongoDB URL. Yeah, this is our MongoDB. Here, repeat for a second. Here we can see the history and the user. In this history, we are loading all the details. In history, we are storing user mail, image URL, prediction, confidence, and timestamps for specific user. Then after these are the login details. Wait a minute, it's loading. Yeah, these are the login. Every user has his ID, username, password, and Gmail ID. And mainly we are using a hash function. And this page says that our API function is running. This is our main.py. All the functions are called into this. Yeah, this is the enable course, and here is the MongoDB string, and these are the requirements: tail fruit, user, and history. And this part of the code loads the model once the startup, and this part of the code calls the predict function, reloads the image, gets the prediction. Then after adds the this is the endpoint. And here it is the endpoint, and it is which I showed you the black screen. And this is where we call the sign in API, and this is sign up API. Then after we call the save prediction, and then after we call the get history. Now we will dive into the PPT, and this is an architecture diagram. In this architecture diagram, mainly a user uploads an image here, and it goes to the backend. Then backend contains API, handle image, and communication with the AI model. This is sent to the pre-processing future extraction, and in this feature extraction, the resize, normalization, and extraction features. This is sent into the Swin model, and predicted fruit quality. And then after this, the values, the final output is sent into the database and into our deployment, and which goes to the web application. This is our overall architecture. And major project learnings. Our major project learnings in stale fruit detection is full stack integration, Swin transformer, experimentation and debugging, vision transformer, API development. These are the major projects learning. And these are project execution challenges. These left side blue parts are basic execution challenge, and these right side parts are most affected challenges which we have faced. Model deployment and training, API integration, model performance, and handling large files. This is all the challenge we have faced. And here we can see the WIT transformer architecture, and it is the Swin transformer architecture. And now, why only Swin transformer? This is superior performance on visual tasks, hierarchical feature representation, Windows-based self-attention, better efficiency and scalability, flexible and downstacks. Now, our model mainly says scanning is greater than greater than automated scanning. Now, here are the three models: CNN model, vision transformer model, and the Swin model. In this global context, understanding is strong in Swin model. Hierarchical feature extraction is strong in Swin model, and computational efficiency is high in Swin transformer. Working well in small data sets in high in Swin transformer. Performance and visual tasks is high in the transformer. Overall, we can see the Swin transformer is the main step. Yeah, and our deployment platform. In front end, we are deploying in Netlify, and the fast API model we are deploying in Railway, and Express AI we are deploying in Railway using a Node.js backend. And this is a MongoDB Atlas. With MongoDB Atlas, we are deploying. This is the project status. The present project status is prediction the model, front end and back end, user interface, and deployment. We are present working on it. And then after application goals, the main application goals are prediction model, responsive design, user friendly application, smooth user experience. Thank you.